Welcome back to Daily Dose of Space. Today we're talking about something that sounds simple at first, almost harmless. A coincidence. But this one is different. This coincidence appears everywhere we look in the universe, in the laws of physics, in the structure of space itself, and in the fact that anything exists at all. Because when scientists started measuring the universe more precisely, they noticed something unsettling. A handful of completely unrelated numbers, constants that should have nothing to do with each other, are tuned just right. Not approximately, not loosely, but so precisely that changing them even slightly would erase stars, galaxies, chemistry, and life itself. And the question is not whether this is real. The question is why it works at all. A universe balanced on a knife edge. When we talk about the universe, we usually imagine something vast and powerful, something chaotic and violent. But behind that chaos is an invisible framework of numbers that quietly decide how reality behaves. Gravity has a strength. Electromagnetism has a strength. Particles have masses. Space itself has an energy density. These values are not chosen by us. They are measured, and they simply are what they are. The strange part is that if gravity were just a little stronger, stars would burn too fast and collapse early. If it were slightly weaker, stars would never ignite at all. No long-lived suns, no heavy elements, no planets. Electromagnetism sits in a similarly narrow range. Change it just a bit, and atoms become unstable, chemistry collapses, and complex matter never forms. Even the ratio between the masses of fundamental particles, like electrons and protons, seems strangely optimized for stable atoms and long-lasting structures. None of these constants were designed with life in mind, at least not according to physics. And yet, they behave as if the universe was carefully balanced to allow complexity to grow over billions of years. This is not philosophy. It is not speculation. It is something that appears again and again in equations, simulations, and observations. And this is where the coincidence begins to feel uncomfortable. The cosmic accident that should have ended everything. One of the strangest examples involves something called dark energy. This is the energy of empty space itself, the force responsible for the accelerating expansion of the universe. When scientists first tried to calculate how strong dark energy should be using quantum physics, they got an absurd answer. Their prediction was off by a factor of about 10 to the power of 120. That is not a typo. It is one of the worst theoretical predictions in the history of science. If dark energy were even slightly stronger than what we observe, the universe would have expanded too fast for galaxies to ever form. Matter would have thinned out instantly. No stars, no planets, no observers. If it were slightly weaker, gravity would eventually reverse the expansion and collapse the universe long before complexity could emerge. Instead, dark energy sits at a value that allows galaxies to form, evolve, and persist for billions of years before acceleration becomes dominant. It is not zero. It is not large. It is just right. And the more we refine our measurements, the more precise this balance appears. At this point, coincidence starts to feel like an understatement. Too many coincidences to ignore. One coincidence might be dismissed as luck. Two might raise eyebrows. But the universe presents dozens. The density of matter in the early universe was almost perfectly balanced between expansion and collapse. The initial fluctuations in density were small enough to avoid chaos, but large enough to seed galaxies. The speed of light, the strength of nuclear forces, and the behavior of quantum fields all fall into narrow life-permitting ranges. These parameters are not linked by any known theory. They do not derive from a single equation. They simply coexist. Physicists call this the fine-tuning problem, but that name almost hides how strange it really is. It is not that the universe is friendly to life. It is that the universe seems hostile to every version of itself except this one. Change almost anything, and complexity collapses. And this leads to an uncomfortable realization. Our existence does not feel generic. It feels improbable, so improbable that some scientists began questioning whether this universe is the only one. The multiverse, solution or escape hatch. One proposed explanation is the multiverse. The idea is simple in concept and extreme in implication. If there are enough universes, each with different physical constants, then eventually one of them will randomly end up like ours. We would naturally find ourselves in that universe, because only such a universe allows observers to exist. This explanation does not require design. It does not require intention. It only requires an enormous number of unseen universes beyond our observable horizon. The problem is that the multiverse is currently untestable. There is no confirmed way to observe other universes or interact with them. It explains the coincidence by moving it somewhere else, outside our reach. Some physicists accept this reluctantly. Others remain deeply uncomfortable with it. Because once you accept the multiverse, the laws of physics stop feeling fundamental and start feeling environmental, like the weather. And that changes how we think about reality itself. Are we asking the wrong question? There is another possibility that scientists rarely discuss publicly because it sounds unscientific even when handled carefully. What if these constants are not random at all? Not necessarily designed, not necessarily intentional, but constrained by deeper laws we do not yet understand. It is possible that all physically consistent universes naturally converge toward similar values. That what looks like coincidence is actually inevitability. The problem is that we do not yet have a theory capable of proving this. Modern physics is powerful, but incomplete. Quantum mechanics and general relativity still refuse to fully merge. Dark matter and dark energy remain largely mysterious, and the origin of the constants themselves is unknown. So we are left in an uncomfortable position, aware of the coincidence, unable to explain it, unable to ignore it. Why this matters more than it seems. This is not just an abstract problem for physicists. The fine-tuning of the universe forces us to confront a deeper issue. Whether reality is random, inevitable, or something else entirely. It reminds us that our existence rests on a fragile balance that could have failed in countless ways. And perhaps the most unsettling part is this. The universe does not appear chaotic at its foundation. It appears delicately structured. Whether that structure has meaning is still an open question. But the coincidence remains, written into the equations of reality itself. And until we understand where these numbers come from, the universe's biggest coincidence will continue to stare back at us. Silent, precise, unexplained. And maybe that's the real mystery. Not that the universe is big or violent or strange, but that it works at all. Thanks for watching Daily Dose of Space.